Hi there, my name is Colleen Spiegel, and in this video we're going to explain the concepts of voltage, amps, frequency, and power using the nameplates that are on the back of most appliances, and then also through a water analogy. So if you look at the back of any major appliance, like your dishwasher, washer, dryer, you should see a nameplate. And the picture on the screen is actually a nameplate from my old Dell computer. And you'll see a bunch of numbers on there. And of course, most people don't understand what that actually means because it really doesn't concern them as long as their appliance works properly. So the nameplate actually tells you the type of electricity that the device expects and how much it's actually going to consume. The nameplate specifies your voltage, your current, your frequency, and your wattage. And you can kind of think of it like a nutrition label for electricity. So your voltage is the required electrical push for the device to operate safely. So in the United States, it's 120 volts for most electrical outlets, but there are a few electrical outlets in your house that require 240 volts for large appliances like your dryer. Your current is the amount of current the device draws during operation. So for most small appliances in our household, this is going to be a small draw, like 0.8 amps, 2 amps, etc. There are some appliances like your dryer that's going to require a larger amount of amps, which is why the voltage is also higher. So those typically need thicker wires and larger breakers. Your frequency is the rhythm that your appliance needs. So this is how fast the AC voltage alternates per second. So in the United States, that's 60 hertz, and in Europe and Asia, that's actually 50 hertz. So motors and transformers are sensitive to this frequency, and if you plug in an appliance with the wrong frequency, you can have overheating, speed changes, and it might not function at all. This is also why in Europe you have different electrical outlets than in the US. So to understand these electrical terms a little bit more, we're going to look at the theory. So we have voltage, current, and resistance. Voltage is the difference in potential between 2 points in a circuit. So if one point has more energy than the other point, that difference is called voltage. This is measured in volts, which is the V on the nameplate. Current is the flow of electrons between 2 points in a circuit. This is measured in amps, so that's denoted as an A on your nameplate. And resistance is the electrical resistance, or the difficulty for the current to flow between 2 points in a conductor. And this is measured in ohms. So you'll see this kind of omega sign on your nameplate. So these three are related through an equation called Ohm's law, which is V equals IR. So voltage equals current times resistance. So you thought you weren't actually going to use math today, and you did. So this can also be explained using an analogy of water flowing through a pipe. So the current is analogous to water flow through a pipe, and the voltage is actually analogous to the pressure in a pipe. So if the voltage is higher or the pressure is higher, a stronger current will flow. In this figure in the video, you'll see that the pressure or the voltage with no current and the pressure voltage with current. So that's when the valve is closed, there's nothing flowing, and when the valve is open, it starts to flow. And that's the same as your household electrical switches. So the other unit that's on the nameplates are called watts. So this is power. It's represented by 1 amp of current through a circuit with a potential difference of 1 volt. So again, it relates voltage and current. So the equation for this is P equals IV, where P is power, I is current, and V is voltage. So for more tips and educational videos, please subscribe to our channel.